This is First Coast Math Clinic with Lesson 2, Division Properties of Exponents, from Unit 10, Exponents, from our Pre-Algebra and Algebra curriculum. So our goal is to use the quotient and quotient to power properties to simplify expressions with exponents. So the two properties we're going to get into in this video are the quotient property and the quotient to power properties. So let's go through these two properties. So our quotient property starts with if I have a to the m power over a to the n power, well, we're dividing, so that's the quotient, right? Because any division property or division problem is the result is the quotient. So when I'm dividing my bases, a to the m over a to the n, well, what are we going to do with those exponents, m and n? We can subtract them. So we're going to keep our base, which in this case is the a. So we're going to keep that a. And to simplify, we're going to subtract our exponents, m and n. So our quotient property says that if we're dividing our bases, we have our fraction, a to the m over a to the n. We're going to keep our base a and then subtract our exponents, m minus n. So what does that look like in terms of a problem? So I have x to the 7th over x to the 2nd. So to simplify this, this is basically going to be keeping our base, x, and then 7 minus 2, giving us x to the 5th. Now writing out what this actually looks like, all right, x to the 7th over x to the 2nd, what we're actually doing here is we know x to the 7th means we have 7 x's. 6, 7. And x to the 2nd means you're multiplying 2 x's, x times x. Well, we can divide our x's out, so we're canceling out these x's. So cancel and cancel 1 and 2. And how many x's do we have left? In our numerator, we've got 5 x's left. And then using our product property, we know that, well, each of these exponents is 1. We're multiplying our bases, so adding up those exponents, 1 plus 1 plus 1 plus 1 plus 1 gives us x to the 5th, right? So another way to think about what we're doing here, right? So two ways to get this, and this is just kind of our explanation of what's actually happening here, right? So we're literally just canceling out our bases, and that's where we get the subtraction from. So that's our quotient property. Now our quotient to power property is if we have a fraction, so a over b to the m power. To simplify this, we're going to distribute that exponent, m, inside the parentheses. So we're going to raise a to the m power and b to the m power. So what does that look like? So let's say we have something like this. Y over x, all to the 4th power. Well, we can distribute that exponent of 4 inside the parentheses. So we're going to have y to the 4th power over x to the 4th power. So those are the two main properties we're using in this video, the quotient property and quotient to power property. We are incorporating some of the properties from lesson 1, the multiplication property of exponents. If you want to review those properties, a link to that video is going to come up right now, as well as at the end of this video. We're going to go through a number of examples in this video. So let's get into a couple examples. So for number 1, we've got y to the 8th over y to the 3rd. So I want to write out what this actually means before we get into solving it. We're going to do this two different ways. Just want to make sure everyone understands what we're actually doing here. So y to the 8th means we've got y times itself 8 times. So that's 8 y's. And then the denominator, we've got y to the 3rd. So that's going to be y times y times y. And when we have any fraction is division, so we could divide out and basically cancel out equal number of y's, numerator and denominator. So 1, 2, 3, and what do we have left? We've got 1, highlight this, we've got 1, 2, 3, 4, 5 y's. So knowing that our power here is just 1, and when we multiply our bases, we're going to add up the exponents. This is going to be y to the 5th power, okay? So that's kind of just writing out exactly what this means and canceling everything out. Using our quotient property, we're saying, all right, well, where do we have more y's? We've got y to the 8th in our numerator over y to the 3rd, so we have more y's in our numerator. So we can just subtract 8 minus 3, keep that in our numerator, right? Because it's basically over 1. We don't need to put the 1 in there, and our answer is going to be y to the 5th. Now I want to compare that to number 2, right? So number 2, we've got x to the 2nd over x to the 5th. So if I write this out as well, so our numerator is x times x, denominator is x times x. So we've got 5x's. Now if I do the same thing and cancel it out, right, now we have 3x's remaining in our denominator. And we know that whenever we cancel out our terms, we're not left with 0, we're replacing it with 1, right? So this becomes 1 over x to the 3rd, okay? So again, what we're saying here, right, is basically where do we have more x's in our numerator or denominator? We've got x to the 2nd in our numerator, x to the 5th in our denominator, so we have more x's in our denominator. So if we're using our quotient property, we're replacing our numerator with 1 and saying in our denominator, if I want to simplify this, I could just subtract 5 minus 2, and I get 1 over x to the 3rd, okay? And again, just comparing number 1 and number 2. Number 2, my answer is going to go in my denominator. My x to the 3rd is going to be in my denominator because we have more x's in the denominator. Number 1, our variable is in our numerator because we have more terms in our numerator. For number 3, x to the 3rd over y to the 2nd. So we're going to use our quotient to a power rule. So let's raise each term to the 4th power. So we can raise x to the 3rd to the 4th over y to the 2nd to the 4th. Now we could use our property from lesson 1, the multiplication property of exponents, power to a power. So if I have a power to a power, I can multiply these exponents. So this answer is going to be x to the 12th over y to the 8th. At this step, our bases are different, x over y, so we can't simplify this any further. So this is going to be our answer for number 3. Okay. All right, let's get into example 4. So for number 4, we've got x to the 6th y over x to the 3rd y to the 7th. So let's figure out first, where do we have, let's work with our x's first, and where do we have more x's? We have more x's in the numerator, right? X to the 6th over x to the 3rd. So when we subtract, we're going to keep our x's in the numerator, so this is going to be 6 minus 3. Now looking at our y's, right, I have y over y to the 7th. If I don't see a power on that y, it's just going to be 1. Where do I have more y's? Well, I have more y's in the denominator. So we're going to keep our y's in the denominator. So this is going to be 7 minus 1. So x to the 6 minus 3 is going to give us x to the 3rd. Y to the 7 minus 1 is going to give us y to the 6th. And we can't do any simplifying further. So that's going to be our answer. Number 5, we've got x to the 9th, y over x to the 3rd, y to the 4th, all to the 2nd. Let's simplify inside the parentheses first, and then we'll distribute. So we'll do the same thing. Let's figure out, start with our x's and figure out where do we have more x's here. X to the 9th over x to the 3rd. Well, we have more x's in the numerator. So if we've got our quotient property, we're going to be subtracting 9 minus 3. because again, we've got 9x's in the numerator, or x to the 9th in the numerator over x to the 3rd in the denominator. For the y's, we've got y to the 1st over y to the 4th, so we've got more y's in the denominator, right? So we'll do y to the 4th minus 1. So this is going to give us x to the 6th, y to the 3rd. And then let's put that exponent of 2 back. Now we've got a quotient to a power. So let's raise our x to the 6th to the 2nd, y to the 3rd to the 2nd. So we're raising our numerator and denominator to the 2nd power. Power to a power, we're going to multiply. So we're going to give us x to the 12th, y to the 6th, and that's going to be our answer. Let's move on to example 6. Yeah, so for example 6, we've got a couple things happening here. We've got 3x to the 2nd y over 4x to the 5th y to the 5th times 2x y to the 7th over 3xy, and we're multiplying. So we're combining our multiplication properties of exponents and our division properties of exponents. I prefer to start with the multiplication. So let's start by simplifying this multiplication and multiplying our numerators, multiplying our denominators. So let's do one step at a time. So I'm going to rewrite this as one fraction, just grouping together the terms that I'm going to multiply, right? So and then my numerator, I'm going to multiply let me highlight this, the 3 and the 2. That's 3 times 2. And then x to the 2nd and x. And then y and y to the 7th. And in my denominator, I'll do the same thing, y and 3. And then let's do x to the 5th, x. And then y to the 5th and y. Now we could use our multiplication properties of exponents to multiply everything. So on my next step, I'm going to get 3 times 2 is 6. I'm multiplying my bases, so I'm going to add my exponents. X to the 2nd times x to the 1st is going to give me x to the 3rd. Y to the 1st times y to the 7th is going to give me y to the 8th. Y to the 3rd, which means 4 times 3 is 12. Y to the 5th, which means x to the 5th times x to the 1st is going to give me x to the 6th. And then y to the 5th times y to the 1st is going to give me y to the 6th. So now let's simplify this. And to simplify this, let's start with that 6 over 12. So 6 over 12, we know that if we factor this, right, this factors into 1 times 6 and 2 times 6. So the 6 is our GCF, they cancel out, right? Those are our coefficients, so we're not subtracting these. We're going to factor and divide them out like we normally would. So that's going to reduce to 1 over 2. All right, so I'll write my answer here. I've got x to the 3rd over x to the 6th. So we're dealing with the x's now. Where do we have more x's? Well, we have more x's in the denominator. So this is going to be, in my denominator, x to the 6 minus 3. Well, x to the 6 minus 3 is going to give me x to the 3rd. And what about the y's? I have y to the 8th over y to the 6th. Where do I have more y's? I have more y's in the numerator here. So that's going to be y to the 8 minus 6. So 8 minus 6 is 2. Okay, so our answer, we're multiplying by 1 in the numerator, so we don't really need to put that 1 in. So our answer should be y to the 2nd over 2x to the 3rd. So that's going to be our answer. Number 7, our last example. Let's simplify as much as we can inside the parentheses first, and then we'll distribute that exponent and use our quotient of powers. So we've got 3 over 4 to start. Not a whole lot we could do there. So we'll keep that 3 over 4. Our x's, we got x to the 2nd over x. So where do we have more x's? I have more x's in the numerator, so it's going to be x to the 2 minus 1. The y's, I have y to the 1st over y to the 3rd. Where do I have more y's? That's in my denominator, so it's going to be y to the 3 minus 1. And the z's, well, I have more z's in the denominator. So it's going to be z to the 5 minus 4. So my next step, this is going to be 3 over 4. X to the 1st. I'm going to put the 1st in there just so we can easily see what we're multiplying by in the next step. X to the 1st in the numerator, y to the 2nd, and then z to the 1st in the denominator. Now let's put back in that 2. Okay. So our quotient to a power. Now we've got to raise everything in here to the 2nd power. So this is going to be 3 to the 2nd power, x to the 1st to the 2nd power, 4 to the 2nd power, y to the 2nd to the 2nd power, z to the 1st to the 2nd power. 3 to the 2nd power is going to give us 9. X to the 1st to the 2nd power, where we use our power to a power rule, so this is going to give us x to the 2nd. Y to the 2nd power is going to give us 16, or excuse me, 4 to the 2nd power is going to give us 16. Y to the 2nd power, so again, power to a power. We're multiplying these exponents, so this is going to give us y to the 4th, and z to the 1st to the 2nd. We're multiplying those exponents, so this is going to give us z to the 2nd power. Now this step, I've got 9 over 16, nothing we can reduce there. I've got x as my base in the numerator, and then y and z. I can't reduce my variables there, so there's nothing I can reduce there, so this is going to be my final answer for number 7. So this video was lesson 2, division properties of exponents. If you like this video, leave a like, comment, and subscribe. If you want to see some additional topics or videos for additional math topics, leave the topics in the comments. Again, I hope these videos are helping you guys. If you like these videos, leave a like, comment, and subscribe. First Coast Math Clinic.